Morning, Margie. Good morning, grade 10. Okay, I have only here Margie. Supposed to be for grade 10, we have two students online, Margie and Dimitri. But Margie is actually answering in the module. Okay, so by the way, for your project, okay, we are done with the discussion with the gas laws. This is for the fourth quarter, weeks 1 to 4. Okay, and again, I'll be giving examples today, right? For these laws. How can we apply these laws? But apparently, for the benefit of everybody, with regards to the project, I already updated the LMS. It is in your LMS already. The instructions given, project objectives, you have the main objective of this project is to, number one, develop a creative thinking skill, develop a deep logical understanding of the lesson, create a learning resource material based on the science concept, okay? Build a sense of resourcefulness and a sense of responsibility, okay? Create a quality output to be exhibited by the school, and of course, to really understand the discussed science concept, okay? That's our main goal or objective, okay? Instructions given here, already given the instruction here, create a learning resource material out of our topic for the fourth quarter, module 1, weeks 1 to 4, illustrating the science concepts that we had discussed. These include, but not limited to, number 1, digital outputs, blogging or video documentaries narrated. Second is physical outputs, 3D of science concepts, diorama, miniatures of science concepts, the actual science concept if possible. I'm encouraging everyone to make the physical output since it has the biggest grade. Make it as attractive as possible with your own creativity, okay? And in any materials of your choice. Note that this is your output for this school year, and it will be exhibited as soon as we are allowed to do so. I'll be in school every Friday to check your outputs. Deadline. This will be the deadline of this will be May 13, 2022 at 5 p.m. That's Philippine time. Okay. And of course, your module, I already incorporated it here. So you can download this in your own end if in case you would like it to be printed. So it will be printed also in school. Right? So for the example, let me share again my screen. Okay. Hold on. This is the example. Okay. A 45 ml gas exerts a pressure of 760 millimeter of mercury. Okay. What is the volume of same gas if pressure is increased to 800 millimeter of mercury at the same temperature? Means at the same temperature, it's constant. Okay. Right? So again, in dealing with problems concerning gas or gas laws, you need first to check on the given, or in dealing with any scientific problem, you need to check first the given. What are the given there, Margie? What are the given there? What are the given there? Margie, are you still with me? Okay, what are the given there? Okay, 45 ml and 760 millimeter of mercury. So what is 45 ml there? If you're going to check, please also, before anything else, check on what is being asked in the problem. The problem is asking about volume and pressure. Okay, volume and pressure. Since the problem is talking about volume and pressure, what gas law correspond to that question? What gas law? Margie and Dimitri. The question is asking about volume and pressure. So what law correspond to that question? Margie and Dimitri, are you still with me? Can you hear me? We are done with the discussion, correct? Okay. What law corresponds to volume and pressure? Because the question there, the problem there is talking about volume and pressure, correct? Volume and pressure everywhere. Okay. So what law corresponds to volume and pressure? Based on our discussed topic, gas laws. It belongs to what? What concept? What law? Let me check on the chat box. Boyle's law. Okay. It corresponds to Boyle's law. Okay, because Boyle's law is talking about pressure and volume. So since Boyle's law is talking about pressure and volume, we need to extract the given, okay, based on Boyle's law. So the given there is V1. Why V1, chair? V1 because we started with this volume, correct? And the question here, the V2, what is the volume of the same gas? This is the V2, okay? This is the V2. Same gas if pressure is increased to 800 millimeter of mercury. Okay, the question there, what could be the volume if the pressure exerts or increase at 800 millimeter of mercury? What will happen to the 45 ml? That's the question. So the 45 ml there represents V1. Okay, correct? Okay, and the pressure one, since this is Boyle's law, pressure one represents 760 millimeter of mercury. That's the pressure one. Okay, V2. Okay, V2 is unknown, of course. Looking at the question, what is the volume? This is the V2. Okay, we're looking at, or the problem is asking about the volume of same gas if we will increase the pressure to 800 millimeter of mercury. Okay, this is unknown. Okay, and the pressure 2 is given there, correct? The pressure 2 is equal to 800 millimeter of mercury. So we raise the pressure to 800 millimeter of mercury. Okay, what is the formula? Okay, what is the formula in Boyle's law? Check on your notes. The formula for Boyle's law. Dimitri and Margie. The given is already there. Okay, we already plotted the given. Now it's time for us to extract the formula. What is the formula under Boyle's law? Formula under Boyle's law? Correct. Okay. P1 times V1, P1 pressure 1 times, okay, let's have this one. Correct? Correct, Dimitri? Okay. Pressure 1, okay. Simple formula. Okay. Pressure 1 times V1 or volume 1. And it is already given there, correct? Is equal to V2 V2 P2 times V2. That's the formula, correct? Okay. Since this is the formula, we can now substitute. Okay. What is the value of our P1? Value of P1? Anybody? P1 there is 760 millimeter of mercury. 760. Take note of the units used. Millimeter of mercury. Okay. Times your volume 1, which is 45 ml. 45 ml. Okay. Is equal to P2, which is 800 P2. This one, 800 millimeter of mercury times the unknown. Okay, the unknown is V2. Okay, substitute again. Okay, what should we do next? Based on the concept they're given, what should we do next? Since you already substituted the given on the formula according to Boyle's law, so we are looking for V2. Okay, what should we do next? What should we do next? Let me check your mathematical skills. Multiply. Okay, but you cannot multiply V2 to 800 millimeter of mercury. Correct? You can multiply this because it has actually value. But how about unknowns? Remember, in your mathematics, you cannot multiply unknowns. Correct? What should we do next? We need to extract the unknown. How can we extract the unknown in this case? Think about it. How can we extract the unknown? Subtract 800 from subtract 800. No. Remember that you need to have the value of B2. This one. Okay. Based on the given and based on the formula there, how can we extract B2 there? Okay. And we cannot multiply this because this is unknown. B2 there is unknown. It doesn't have any value. It's unknown. Okay. But here we can actually multiply. And this is the base formula. We can multiply this one, of course, because it has actually given test values. But how about this one? What are the possible ways on computing this one? Use a scratch paper in your end. Okay, I will give you, wait, I'll give you around 5 minutes to think about it over. 600 from P2. 600. Where did you get the 600? Where did you get the 600? 800. Subtract the 800 from P2. The 800 from P2 also. Subtract. What do we need to subtract? The 800. 800 is the value of your P2. Think about it. And let me share it in the class. Please share it in the class after. I'll give you 5 minutes. Still have time. Okay. In my clock, it's 9:44. So we will continue by 9:49. Okay. I will give you time to think about this because these are just basic concept or basic mathematical equations. Okay. Margin and Dimetri, please use a scratch paper. And so in solving this, because you'll be engaging with a lot of this in your major exam. Okay. I am giving you higher order thinking skills questions and higher mathematical equations because you're now in grade 10. Okay. And you'll be dealing with this in your senior high and college. Right? Okay. My clock, it's 9:45. Again, you still have time. Please do the computation in your end, in your scratch paper, and share it in the class. Okay, time is up. Okay. What is your answers? Let me see your answers. Share it in the class. How can you solve for V2 in this case? Margie and Dimitri are still with me? Okay, how can you solve this one? Is Margie around? Margie? I know that you're capable, Margie. Okay. How can you solve for V2? Okay, Margie, how can you solve for V2? Am I choppy in your end? Am I choppy in your end? Huh? Are you sure? How about Dimitri? Am I choppy in your end, Dimitri? Ah, okay, okay. So it's with, okay. So how can you solve for V2? What should we do next? Again, math and science are actually has similarities. And this is one of their similarity. Okay. In physics and chemistry, they're actually similar. Okay, what should we do next? To solve for this, we need to cancel this over. Okay, we need to cancel 800 millimeter of mercury. How can we cancel? Divide both terms with divide both terms with 800. Okay, 800 millimeter of mercury. 800 millimeter of mercury. Okay, so we already divided both terms with 800. Okay, the next thing to do is to what? Is to cancel 800 millimeter of mercury. Okay, after which we have 700 millimeter of mercury times 45 ml is equal to V2. Okay, we extracted V2. Okay, over 800 millimeter of mercury. So there you go. We can now substitute for our V2. Okay, 760 times 45 ml. Okay, 760. But before anything else, we can actually see like terms there, correct? You can actually see the same what? The same units used. So we can cancel it over also. Okay. Because we are actually looking for V2. And volume usually is in ml and liters. So we can cancel this over. Okay, try to look at this one. We can cancel this one. Okay, because this is like terms. Okay. Cancel, cancel. Okay. So we can now move to the computation. Okay. 760 times 45. What is 760 times 45? 760 times 45 ml. It's 3,000, 34,200. Okay. 34,200 ml. Okay. It's equal to V2 divided by 800. Okay. Since we cancel out the units, millimeter of mercury, correct? Okay. So 34,200 divided by 800 divided by 800. The answer is, what is the answer? Okay, we have 34,200 divided by 800. We have 42.75. Wait, 760. Okay, correct. So 34,200 ml divided by 800, the result is 42.75 or 75 or 43 ml. Is equal to V2. Do you have any questions so far? Question. Questions? Is Margie still around? Is Margie still around? Margie? Okay. Question, Dimitri, do you have any question? $171. Where did you get the 171? Ah, okay. All right. I will give another example by next meeting. Hopefully, we still have a lot of time. Okay. In other laws, hopefully also you can maximize your science, your mathematical skills for this, because science and math are actually relevant. They're really relevant. Talking about physics, chemistry, we usually use the mathematical equations or the concepts, mathematical concepts in those problems, right? I think that will go for today, class. Thank you for participation, Margie and Dimitri. Have a nice day, everyone. Your attendance already recorded. Goodbye. Take care. Enjoy the rest of the day.